is Techstrong TV.
Hey folks, welcome back to the Open Source Summit. We're here in lovely Dublin, Ireland, and we're talking with Marcos Figueiredo, who's the Director of Global Platforms and Solutions and Offerings for Fujitsu. And turns out Fujitsu's been doing a lot of work with Postgres over the years in Japan, and now they've also done some interesting stuff with containers, and they're going beyond Japan. They're going to be here in Europe, and they're coming to the US. So Marcos, welcome to the show.
Yeah, nice to be here. Actually, it's a great opportunity to spread the word that we're actually going outside of Japan now, and we're focusing on bringing a lot of the heritage actually we have around open source and Postgres to the other markets, right? So we are expanding in the US, expanding in Europe. Of course, we have a footprint in Asia, but we think it makes sense now to tell, hey, we're doing this, we have expertise, we're actually giving back to the community. And our main focus is around Postgres. That's our main software, but we are actually expanding. We're doing a lot of work around containers, Kubernetes especially, because there's a lot going on this space of databases, and people need some of the automations and toolings that you can get with containers. So it's all about DevOps, how you can actually make it easy for folks to tap into a database, right?
To that point, we have been hearing and talking about stateless apps for containers forever and a day. Now we're finally starting to see some more stateful applications. And it's a bit of a debate. There are some people out there who are like, there's no way in heck that you should be storing data on a Kubernetes cluster. So what drives people to put the database on the cluster, and what needs to be done to enable that?
Right, that's a great question. So something I keep hearing from clients, it's really, why should I put a database actually on containers? That's probably the last thing I want to put on containers because I might not get the performance. But I think we got to a point where we have mature enough tooling to get us to deliver the same capabilities that we were getting on traditional bare metal or virtualized environments. Now we have all those capabilities into the containers. So we have actually launched early this year our full capability around OpenShift, for example. They call level 5, right? Operators, they don't have a standard necessarily, but level 5 basically means we have full auto-scaling, monitoring, and capabilities to allow the developer to connect to the database without knowing too much about it. And on the same time, he can tap into high-performance storage, high-performance compute, if those things are connected to their Kubernetes cluster, right? So because of this evolution of the toolings, I think we are to the point where we're going to see a lot of these stateful applications actually now really being migrated into containers. So I think we are at the tipping point from that perspective.
There are a lot of people who do not have an existing data storage architecture that they can call externally, and so if it's greenfield, you got to have some data somewhere, so likely is you're going to attach it to the cluster anyway because that may be all you have.
Correct. Yes, and there is a lot around, there's a question around NoSQL tends to be more suitable for this types of environments, especially greenfields, because developers, they don't need to talk with a DBA, right? So they can just go out and then connect to a NoSQL and then start using without worrying too much about, well, what's my schema going to look like, or how do I optimize this to make the application will not perform? The funny thing is, when we got Postgres, which is a traditional object relational database, and we bring operators around Kubernetes, we actually give a lot of those capabilities back to the developer. So they don't need to worry too much. Yeah, still there is a need to think about how they're going to scale long term. But when you start putting those toolings, then now they get the auto scalability that they would get using a non-SQL, right? Without having to worry about to worry too much about how the thing's going to shard in the future, or if they're going to get a lot of data spread all over. So yeah, again, back to the tooling, I think what we're doing around containers, it's really provide a tool set to allow, even if you're starting from scratch, to allow you to grow in a way that application can become an enterprise at any moment, right?
We have been hearing about the developers don't need no stinking DBA thing for a long time, but it seems like what happens is they get about into their third or fourth database and they go, oh, well, maybe I need a DBA, but I don't want to admit it's a DBA, so I give it a different title or a different job function.
Right.
So what is the relationship between developers and DBAs as we go forward, and what should it be?
Well, I think more and more DBAs will have to understand what the challenges are for the developers and move away just from the little silo. So I think what DevOps really does is really breaks the silo. So now you need to understand the other sides of the equation, right? So the same thing we have with DBAs and developers, you have between DBAs and infrastructure architects, right? So all of that has to go away to have DevOps to work and to realize the full benefit of operating in an agile way and leveraging what DevOps can deliver. So I think DBAs will potentially have a change of title, or they will have to understand better what the needs are, and then things will start to change in terms of how developers and DBAs communicate with each other. Right? There is a lot around database as a service, which is usually an easy way for developers, again, to tap into databases without knowing about the data in itself, how the data will be structured. But what we're seeing actually back to the containers is that is good to a point when you need to get control back and when you need to scale and then have a full enterprise solution. Container seems to be a better fit actually than just going into the cloud and using a database as a service and forgetting about, hey, I don't need a DBA anymore because I can buy this from somebody else. What we see in reality is that's true to an extent, right? When you get to a level where you really need performance and you really need to make something super reliable, that's where you need a DBA again, right? So that I don't think that's going away. It's just morphing into something a little bit different, right?
Do you think people don't understand enough about the issue with cloud native microservices based applications that are built using these containers is there's a lot of dependencies, there's a lot of calls to data through these APIs, and so performance becomes a much bigger issue than it used to be, and I'm not sure that people understand that going in.
I agree. I think for the most part, we're still very new to it. Again, I see a lot of changes happening, and there's maturity now in terms of some of the architectures are getting to the point where, well, this is becoming really enterprise. Again, for the most part, I think people are still trying to absorb and really understand all the parts, especially when you go to a microservice architecture. It is a shift, right? A complete shift in terms of how you think about the applications, how you think about the data, where the data is going to be located, how you make the call to the right APIs, and how you put performance, reliability, scalability into the equation, right? I still think it's very new for the most part. We've been talking for this about, 5, 7 years maybe, but still it's very new when you compare it to what people have been doing with traditional monolithic applications, monolithic databases. They've been doing this for 50 years, right? And not a lot has changed from the times of the mainframe. Traditional databases into an Oracle today, but when you look into microservices, containers in itself, there's a big shift. So the jump, I think people are learning how to do the jump, but not everybody's there yet. So that's how I see it, at least.
One of the words in the database lexicon that everybody hates is sharding.
Yes.
Can we get rid of sharding, or are we still going to have sharding as we go along?
I think we're still going to have it. So Postgres, the version 15, you see some things the community is bringing into in terms of trying to address that. I honestly don't think we're going to get rid of it. Not in the next 2 releases at least. So that, but again, I might be wrong. That's very debatable. But that's how I see it. I think still going to be there. There are things that we do to work around those issues. I think some implementations get more exposed to it. I think it's not a super complex on Postgres that is sitting on NoSQLs, for example, but still something that needs to be addressed, right? And consider as you architect the whole solution.
as we go along, how automated can all this management of the databases get? And are we looking at, I don't know, maybe some form of AI will come down the pike and we'll have algorithms take care of stuff? I mean, how advanced are we at the moment?
So I think when you look at some of the proprietary implementations, right, you see some of the main vendors calling out autonomous database, which in parts, yes, there's a lot that can be simplified when you put automation, a lot that you can do with machine learning and AI capabilities. But I don't think we're going to eliminate the need to have a data expert. No matter how evolved the AI becomes and our understanding of how we can automate things, I think still going to need a database expert. Again, even if that title changes, still you need somebody to understand how the data needs to be stored, what the things need to be considered as you evolve in the architecture. But there's a lot that can be done in terms of simplify. One of the things is deploying a traditional relational database in containers. It's challenging. It's not an easy task. Again, when you put things as performance scalability in the context, it becomes challenging. You can just stand up a Postgres in a container and say, well, I'm done, I can use it, but that's not reality when you need to scale. And when you get to operators, that's really bringing the automation, right? So it is, how do I do backups in a way that I don't need to really fully understand how the backups work, right? So you want to remove or create abstractions around that to allow developers or even the expert managing the cluster to be able to back up the data, to auto scaling when they sense, well, there's a need to increase capacity or a need to increase compute for this database or more memory. So all those things actually, we have it today. We actually evolving. We are in our second iteration actually on our operator. And we're not just working with OpenShift, right? We're also doing work with AKS, EKS, the Alibaba version of it, SUSE as well, the Rancher. So all of those flavors we are integrating and certifying on how we can actually tap and build our operator to be compatible and portable, because portability is also key here, right? You don't want to get into one specific cluster and be locked into it, right?
One wise guy once said, it's one thing to be wrong, it's another thing to be wrong at scale. That's kind of what we're talking about. So you're going to need a human to kind of manage all that process. Do you think people are trying to do too much with microservices and distributed computing services? And, data has gravity. The laws of physics have not been suspended. So are people not thinking through the physical location of the data related to where the application logic is properly?
Yes, we see that a lot, right? What I see sometimes is when you go to big organizations, what they tend to do is, yes, we need to go into containers or we need to put everything in microservices. And what you see is a lift and shift. So they're not breaking things down, they're not rethinking the whole logic, right? And tapping into why would you go to microservices in the first place, right? They basically get their database, install a Postgres or whatever version of database that they might be using, relational or not. They just lift that from what they had on-prem or even in the cloud running on a virtual machine. They just dump in there, hoping that will address the issue. And that's not the case, right? You have to really rethink. When you're redesigning and you are thinking again scalability, you have to rethink the whole process, right? The whole framework, right? It's not just about I need to use a microservice. And when you talk about data gravity, I think that's really the next big iteration for automation in terms of like operators, for example, is the capability of sensing latency and trying to move data between locations. One of the big things that we see when clients are looking into a Kubernetes deployment, it's really, well, I can be multi-cloud. Right? And everybody's like, oh, multi-cloud, we are multi-cloud. But laws of physics, it doesn't make sense for you to have your data in one hyperscaler and then your application running another hyperscaler and then connecting because you're going to pay for the traffic, all those things. And then the latency might just go to the roof. Again, there are some experimentations in terms of saying, well, data can be spread all over, and we're going to manage, we're going to make it low latency. But when we look into real, true enterprise applications, they are tapping into open source to solve their issues. We see the reality is not that simple, right? There's still a lot of complexities that need to be managed. I think we're getting there, but we're not there yet. So that's a great point. So the multi-cloud still does not eliminate the need to know where your data is located. Are your apps accessing that? Where is your user actually getting into to access your data? So yeah, that's a pain point that people need to consider, and that's not going away.
Are we getting better at moving data? Because when I was much younger, the movement of data was considered the root of all evil. Nothing good can happen when you start moving data around. So have we kind of solved that issue? How close are we?
I think we have a lot more tooling now. And those tools, they are very sophisticated in terms of allowing you to even migrate between different types of databases. One massive trend that we see is people moving away from commercial databases into Postgres. That's why Postgres became so popular, because hyperscalers are adopting. They have a lot of the tools to migrate data from one place to the other. And then there's the promise of portability, right? Which it goes back to, okay, so I can move my data anywhere, and basically I'm free, right? What people don't realize is there's a lot of hooks. When you go to theoretical community Postgres, the vendors are putting a lot of hooks in there where when you try to migrate, the migration will not succeed, not going to be successful because you have dependencies behind the scenes. And that's interesting because for us, Fujitsu, one of the things that we have is we added a few enterprise capabilities to our enterprise flavor of Postgres. But a key thing for us is to maintain 100% compatibility with community Postgres, to the point where the client, they will be with us, not because of our software is unique or lock them in, it's because really we're providing services, or we're actually providing the expertise for them to be able to think about data movement, or how they should approach data. And if they're not happy with us, they can just move that to a community Postgres and then just use that. Or if they want to let their employees to just use community Postgres on the laptops and then bring that to the enterprise version only when they're going to deploy that in production, that's also perfectly fine for us. So, and that's, a lot of people don't realize that, but that's a very different approach. Other vendors you see, there's a lot of around Oracle compatibility modes and those things. What folks don't realize is you're just switching the evils, right? So you were locked into a vendor. Now with this compatibility mode, yes, you can just flip the switch and then have an easy migration, but guess what? You just no longer locked in here, you're just locked in here, right? So that's something that you're really serious considering portability, that's something you should consider, so.
So what ultimately is your best advice to folks about how to get started? Because clearly, this is not simple, and you need some skills to go do this. So where do I go find these skills?
So, of course, the first place I would recommend is, of course, look us up on the web. We are, like I said, a lot of our original documentation, it was in Japanese, but we're doing a big effort on converting that to English. And we are also building capacity outside of Japan. So we're using that expertise globally. So we open to talk with folks, and we also open to interact with the community in terms of providing back expertise. We have committers into the Postgres community that they don't do anything on our enterprise side. They focus on giving back upstream code. So for anyone thinking about containers, DevOps, how does that play into what I'm doing today in terms of relational database? We're here online. You can just search it up, Fujitsu Postgres. You'll find us online. And I'll be happy actually to also reach out and talk with anyone. We have a team of experts globally, and we're more than happy to engage and have some of those discussions.
All right, folks, it's as they always say, don't try this at home. Get some help. Hey, thanks for coming by.
Appreciate it. Thank you so much.
Take care. Yeah. And we'll be back in a few more minutes.